Humans can only see about 6,000 stars, which are bright enough for dark-adjusted eyes to pick them out on a clear sky far from a city. But if we go out at night, at any point in time, we can only see about 3,000 stars, because half the sky will be below our horizon. The translucent part of this sky view marks the half of the sky hidden by the horizon. We are looking due south, with the night sky positioned for Seattle at 9 p.m. on September 10th, 2019. You can see the nearly full moon, Saturn, and Jupiter at about the south horizon. Locating and identifying objects in the night sky isn't easy. Early cultures grouped stars together to form images of men and gods, animals, and familiar objects like a scale to help them keep track of the motions of the sky. We still use these figures today. The International Astronomical Union set boundaries around each constellation. This gives us a very general way of locating objects that move. At this moment, as seen from our Seattle location, the Moon is in Capricorn, Saturn in Sagittarius, and Jupiter in Ophiuchus. Can you identify which constellation Neptune is in? To help us find our way around more precisely, we use two different coordinate systems. The first system, the alt-azimuth or horizon system, is based on our current observing location. We can add the grid lines for this system to our view of the sky. We use the horizon as one boundary and count altitude up from the horizon to the zenith. We start counting around from the north point on the horizon, where we draw the meridian line from the north point through the zenith to the south point. We count eastward around the horizon. Let's spin first 30, then 60, then 90 degrees. We are now looking due east. If we spin another 90 degrees, we will be looking due south. Using this system, the moon is a little more than halfway between our horizon and 30 degrees altitude, and just to the left of the 150-degree meridian, so its coordinates in this system are about 16 up and 148 east of north. Jupiter is past the 210-degree line, so it is at 212 azimuth and about 15 degrees altitude. For anyone standing next to us, these coordinates will help them find an object we want them to look at. But for somebody in another location, say Boston, Massachusetts at the same time, the sky will look somewhat different, because they are about 3 hours around the Earth to the east. Here is the sky from Boston at midnight on September 10th when it is 9 p.m. on the west coast. Notice the position of the moon, already west of south, and Jupiter has set and is below the horizon. So we need a system that is independent of the observer's position and time to locate objects in our night sky. Let's look at the south point from Seattle again. We'll leave the meridian in place, but instead of our altitude and azimuth system, we'll use one based on the locations of the north and south celestial poles. Here we look due north. The lines of longitude of our celestial coordinate system stream out from the north celestial pole near Polaris and Ursa Minor to the south celestial pole. The lines of latitude, or rather declination, circle the poles. Here they are drawn 30 degrees apart. As we spin ourselves eastward, we can see how the meridian lines curve to run from the north to south pole and intersect the horizon at an angle that depends on our own latitude position on Earth. Facing south, we see the Moon, Sun, and Jupiter in the same positions as before, but now our coordinate system gives us their locations in latitude, or declination, and in longitude, or right ascension. Let's add a yellow circle to mark the ecliptic. The Sun appears to move east on this line, making one entire circle each year. Now we'll emphasize the celestial equator. It is the origin for counting north or south in degrees of declination. The ecliptic crosses the celestial equator in two places, and we use the point of one of these, the Aries point, as the starting point for the counting around the equator in hours and minutes of right ascension. As you can see, the Sun lies on the ecliptic, but notice that all of the other planets lie close to this line as well.